Good day, everyone. Today we will discuss Chapter 5, which is Project Scope Management. This topic focuses on how a project ensures that all required work is included and unnecessary work is avoided in order to complete the project successfully. So, what is a project scope management? Project scope management is about making sure that project includes exactly the work that needs to be done to complete it successfully, nothing more and nothing less. It helps project managers clearly define the project's boundaries so everyone understands what tasks are included in the project and what are not. This prevents confusion, extra work, and unexpected changes. In this chapter, we will discuss the main processes involved in project scope management, such as initiation, scope planning, scope definition, scope verification, and scope change control. These processes help ensure that the project delivers the expected product or result. Project scope management consists of 5 important processes. These processes guide the project from its authorization up to controlling any changes that may happen during the project. This includes initiation, which is about authorizing the project or phase. Second is the scope planning, which is about developing a written scope statement as the basis for future project decisions. Third is the scope definition, which is about subdividing the major project deliverables into smaller, more manageable components. Fourth is the scope verification, which is about formalizing acceptance of the project scope. And last is the scope change control, which is about controlling changes to project. There are also 2 types of scopes, the product scope and the project scope. Product scope refers to the characteristics or features of the final product or service. On the other hand, project scope refers to all that work that must be done to create the product. For example, new telephone system project components may include hardware, software, training, and implementation. A simple explanation for this is that a project usually produces one final product, but that product may have several components. For example, a telephone system project may involve hardware installation, software setup, employee training, and implementation. This figure shows the overall framework of project scope management. It presents the 5 major processes involving in managing the scope of a project. Each process includes inputs, tools and techniques, and outputs which help guide the project from the beginning until completion. These processes are connected and work together to ensure that the project includes all the necessary work and avoids unnecessary tasks. First, we have the initiation. Initiation is the first step in scope management. In this stage, the project is officially approved or authorized. This means the organization agrees that the project should start and resources may now be used. Projects usually start because there is a reason or need behind them. For example, a company may create a new project because the market demands a new product or a customer specifically requests a service. Sometimes, projects are initiated due to technological advancements, legal requirements, or social needs in the community. First, we have market demand, responding to market needs. For example, a car company develops fuel-efficient cars due to fuel shortages. Next is the business need, improving company operations or revenue. For example, a training company creates a new course to increase revenue. Third, customer request, fulfilling a client's requirement. For example, an electric company builds a new power station for an industrial park. Next is the technological advance, using new technology opportunities. For example, a tech company develops a new gaming device. Next is the legal requirement, complying with laws or regulation. For example, a company creates safety guidelines for toxic materials, and loss is the social need, addressing social or community problems. For example, an NGO creates a clean water project for communities. These examples show how different factors can trigger the start of a project. For instance, companies may respond to market demands, customer needs, or technological changes. Governments and organizations may also initiate projects to follow laws or help solve social problems. But of course, before a project can be officially started, several important inputs are needed. First is the product description, which explains the features or characteristics of the product or service the project will create. Second is the strategic plan, which ensures that the project aligns with the organization's long-term goals. Third is the project selection criteria, which help managers decide whether the project is worth pursuing based on factors such as profit, market share, or public perception. Lastly, historical information from previous projects help managers learn from past experience and make better decisions. Next are the tools and techniques of initiation. First is the project selection methods are used to measure how valuable or attractive a project is to the owner. They help us decide which project to choose and which approach is best. And there are two main types. First is the benefit measurement methods. It is like scoring models or economic analysis which rank projects based on expected benefits. Second is the constraint optimization methods, which is using mathematical models such as linear or multi-objective programming to find the best combination of project variables. Expert judgment supports this process by providing specialized knowledge to assess inputs and guide decisions. Experts can come from within the organization, consultants, stakeholders, or industry groups. In short, project selection methods give a systematic way to choose the best projects, and expert judgment ensures those choices are informed and reliable. After the initiation process is completed, several outputs are produced. First is the project charter, which formally authorizes the project and gives the project manager the authority to use organizational resources. Second, a project manager is assigned to lead and manage the project activities. Third are constraints, which are limitations such as a budget, time, or available resources. Lastly, there are assumptions, which are factors believed to be true during planning even though they may not be fully confirmed. The most important output of initiation is the project charter because it formally authorizes the project and gives the project manager authority to manage it. Next is the scope planning. Scope planning is where the project team creates a detailed scope statement. This document explains what the project will accomplish and what work will be required to complete it. It serves as the basis for planning the entire project. It starts with product description, next is the project charter, then initial constraints, and last is the initial assumptions. And its main outputs are scope statement and scope management plan. Let us first talk about the two main outputs. The main output of scope planning is the scope statement, which clearly describes the project objectives and the deliverables that must be produced. This document becomes an agreement between the project team and the customer regarding what the project will deliver. Another output is the scope management plan, which explains how the scope will be managed throughout the project. And now, let's talk about the inputs to scope planning. These are the key documents and information we use to define what the project will deliver and how we will manage its scope. First is the product description. This provides details about the product or service the project will create, including its features and functions. Next is the project charter. This formally authorizes the project and gives the project manager the authority to apply resources. It also outlines objectives and high-level requirements. Then we have the constraints. These are the limitations that affect the project, such as budget, schedule, or technical restrictions, and we have to work within these boundaries. And loss is the assumption. These are factors we assume to be true for planning purposes like resource availability or market conditions. Assumptions need to be monitored because if they change, the scope may need adjustment. In short, these inputs provide the foundation for planning the project scope accurately and realistically. Let's go now to the tools and technique for scope planning. Product analysis. Product analysis involves developing a better understanding of the product of the project. It includes techniques such as a product breakdown analysis, system engineering, value analysis, function analysis, and quality function deployment. Next is the benefit or cost analysis. Benefit or cost analysis involves estimating tangible and intangible costs and benefits of various project and product alternatives and then using financial measures such as return on investment or payback period to assess the relative desirability of the identified alternatives. Next is the alternatives identification. This is a general term for any technique used to generate different approaches to the project. There is a variety of general management techniques often used here, and the most common of which are brainstorming and lateral thinking. And last is the expert judgment. It evaluates ideas and supports better decisions based on professional experience. Next is the output from scope planning. The scope statement is the most important, which clearly defines the project scope and provides a basis for future decisions. The scope statement includes project justification, the business need that the project was undertaken to address. The project justification provides the basis for evaluating future trade-offs. Next is the project's product, a brief summary of the product description. The product description is discussed in section 5.1.1.1. Next is the project deliverables, a list of the summary level subproducts whose full unsatisfactory delivery marks completion of the project. For example, the major deliverables for a software development project might include a working computer code, a user manual, and an interactive tutorial. When known, exclusions should be identified, but anything not implicitly excluded. Loss is the project objectives, the quantifiable criteria that must be met for the project to be considered successful. Supporting detail. It refers to additional documentation that supports the scope statement. These details should be organized so they can be easily used by other project management processes. It usually includes important information such as the project assumptions and constraints. The level of detail may vary depending on the type of project or application area. Second is the scope management plan. This document explains how the project scope will be managed and controlled throughout the project. It also describes how scope changes will be handled and integrated into the project. In addition, it evaluates how stable the project scope, meaning how likely it is to change, how often changes may occur, and how big those changes might be. The plan also clearly explains how scope changes will be identified and classified, which is very important, especially when the product details are still being developed. In short, supporting details provide the necessary background information, while a scope management plan guides how the project scope will be controlled and updated. That's all for my part. Now, Francine will discuss the next topic, which is scope definition.
Good day, I'm Francis Navarro. I will be discussing the next topic, scope definition, purpose, improve accuracy of cost, time, and resource estimates, establish a baseline for project performance, enable clear assignment of responsibilities. Purpose of scope definition may lead to increased project costs, rework and delays, lower productive and morale. Inputs to scope definition. First, scope statement description of the project deliverables and objective. Example, building a story schools building with 12 classrooms, a library, and a computer lab. Second, constraints, limitations such as budget, schedule, or resources. Example for this is the project must be completed within 6 months and not exceeding a budget of 200,000. Assumption, conditions believed to be truth during planning. Example, it is assumed that construction materials will be available on time and weather condition will not be delayed. The fourth is other planning outputs, results from other project planning processes used in defining scope. Example, the project schedule, cost estimates, and risk management plan prepared during earlier planning stages. The fifth is historical information, lessons learned, and records from previous similar projects. Example for this is the data from a previous building project showing common delays in material delivery, which helps improve planning for the current project. Next is the tools and techniques for scope definition. WBS templates, previous project or standard templates can guide new projects since deliverables and life cycles are often similar. In this side, the graph shows 5.2 show a sample work breakdown structure for a defense material project where the project is divided into components such as project management, training, data, and facilities. This figure shows an example of a work breakdown structure used in defense projects. The project is broken down into major sections like management, training, equipment, and testing. Each section is further divided into smaller components to make the project easier to manage. Next is the decomposition. Break major deliverables into smaller components until detailed enough for planning and control. Identify major project deliverables including management tasks. Check if cost and duration estimates are feasible at this level, if not, further decompose. The graph 5.3 demonstrates a work breakdown structure organized by project phase, such as planning, design, constructions, and testing. This example shows how a WBS can also be organized according to project phases. Each phase of project contains its own deliverables and tasks, which helps teams monitor progress throughout the project life cycle. Next is the WBS definition, a deliverable-oriented hierarchy that organizes the total project scope. Work not in the WBS is out of scope. Work packages and dictionary, lowest level Y, lowest level items are work packages, descriptions, schedules, budgets, and staff assignments are recorded in WBS dictionary. Assign unique identifiers for hierarchical cost and resource tracking. Use WBS to confirm project scope and plan detailed work. Other breakdown structures. CWBS, OBS, RBS, BOM, PBS, variations for reporting, organization, resources, or manufacturing. Second scope statement updates include any modification of the contents of the scope statement. Appropriate stakeholders must be notified as needed. In Graph 5 form illustrates a work breakdown structure for a wastewater treatment plant project, where the project is divided into design and constructions components. This figure shows another examples of WBS used for wastewater treatment plant project. The project is divided into design and construction phases, and each phase contains detailed tasks such as civil drawings, structural drawings, and facilities constructions. Next topic is the scope verification, is the process of obtaining formal acceptance of the project scope by the stakeholders, sponsor, clients, and customers. The inputs are work results, productive documentation, work breakdown, structure, scope statement, and project plan. The tool and techniques inspection. The outputs is format acceptance. Inputs of scope verification. First, work results, deliverables completed or partial completed during project execution. Example, a finished software model, a constructed bridge section, or a completed market brochure. Next, product documentation. Documents describing the project's product. Example, technical drawing for a building, user manual for a software application, or design specification for a machine. Next is the work breakdown structure, or WBS. Hierarchical breakdown of the project into smaller tasks. Example, project, build a website. Phase 1, design. Task 1, wireframe creation. Task 2, UI mockups. Phase 2, development. Task 2, first, prompted coding. Task 2.2, backend code. The next is a scope statement. Defines project objectives, deliverables, and boundaries. Example, develop a mobile app for online food delivery that allows users to order, track, and pay for food. This does not include restaurant inventory management. Next is the project plan. Explains how the project will be executed, monitored, and controlled. An example for this is a plan including the project schedule, budget, resource allocation, risk management, and quality control processes. Next, for the tools and techniques, inspection, the process of measuring, examining, and testing work results to see if they meet project requirements, also called reviews, audits, products reviews, or walkthroughs. Example, checking a completed bridge section against engineering drawings, or reviewing a software model for bugs. The next is the outputs. Formal acceptance, written documentation confirming that the client or sponsors has approved the project, deliverable, or praise output. Acceptance may be conditional. Example, a signed approval form from a client confirming that the completed website meets agreed specifications, or a project sponsor signing off on a delivered report. And the last topic, scope change control, the process of managing changes to the project scope by approving changes, identifying when they occur, and controlling their implementation. It works with other control processes like schedule, cost, and quality control. Example, updating a software project to include a new feature requested by the client after review and approval, while adjusting schedule and budget accordingly. The inputs, work breakdown structure, or WBS, defines the project scope baseline by breaking it into smaller tasks. Example, for a website project, designed, UI mock-up develops, and fronted coded, backend coded. Next is the performance reports, show project progress, indicating which deliverables are completed and highlighting potential issues. Example, a weekly report showing that 3 out of 5 planned software models are completed and 1 is delayed. Next is change request. Formal or informal request to modify the project scope, either to expand or to reduce it. Example, a client requests adding a new feature to an app or removing a report from the project deliverables. Next is the scope management plan. Describes how the project scope will be defined, controlled, and managed. Example, a plan detailing procedures for approved scope changes, documenting deliverables, and handling scope-related risk. Tools and techniques. Scope change control. Procedures used to review, approve, and manage changes to the project scope. Using a change request from an approval workflow before adding a new feature to a software project. Next is the performance measurement. Techniques to evaluate scope variations and decide if correction actions is needed. Comparing completed deliverables against the original WBS to see if tasks are delayed or missing. Additional planning, revising plans such as modifying the WBS or analyzing alternatives when scope changes occur. Example is updating the project schedules and task assignments after approving a scope change to include extra testing. And lastly, the outputs. Scope changes, approved modifications to the project scope defined in WBS often affected cost, time, or quality. Example, adding a mobile app feature after client approval which increases the project budget and timeline. Corrective action. Actions taken to bring future project performance back in line with the project plan. Reassigning resources to finish a delayed software model on time. Lessons learned. Documented knowledge about scope changes and correction for use in future projects. Recording that delayed approvals, costs, schedule slips, so future projects includes faster approval workflows. Adjusted baseline. The updated project baseline revised to reflect approved scope changes. Example, revising the project schedule and budget after adding new deliverables to reflect the approved changes.